I did turn it live.
Going live.
Oh, it's. Oh, okay. Now we're live.
Yes,
Okay.
That works. Yep.
Okay, let's restart again. All right.
Sure.
All right. Hello, everyone. Welcome to another episode of Quirkcast. This is your host, Tim.
And I'm Mikey.
And this is Sahil. Welcome everybody to a brand new exciting episode of Quirkcast. So before we get started, please do, if you're on YouTube and watching this episode right now, post any comments or questions. We'll get to them during the episode. And if you haven't already, guilt tripping time to join our Discord channel. So you can ask further questions and give further comments that we can then iterate and improve upon. So without further ado, so Tim, I wanted to ask you something. I was recently watching Star Wars and I saw this holographic chess set. Like what's going on for that? Is that possible for us to do, or what do we do about that?
Yeah, I think that's something called hologram. And I think actually we have some technology like that already. So the idea goes like this, right? When we see images with our eyes, right, the only thing that matters is sort of the direction of the light rays that are coming in through our eyes, and we interpret some sort of shapes and whatnot, right? And in fact, it's not necessarily that there exists some 3D object in order for us to perceive the existence of 3D objects. So the technology is there that that you can actually recreate some of that from a 2D screen, where if the 2D screen has the capability to, let's say, shoot laser out in different directions, you could actually create like a fake 3D image behind the screen that to a human would be perceived as 3D, but the actual thing that constructed it is 2D. So that's called a hologram. And I think technology actually exists to create something like that currently.
So are you saying that I can take any configuration of 2D and somehow project onto a three-dimensional looking image?
I guess that's what 3D glasses are doing, right?
Yeah, well, yeah, sort of, because so two things, right? Like to fool the human brain, I think we can do that. It's not that hard. But to do it exactly, I don't even know what that means, to be honest. Like, I guess you can't. Like, we don't have the technology to create exactly the light pattern around a 3D image everywhere, but through a 2D screen, we can do that. I don't know if that makes sense.
I think the light part actually makes it harder. The idea is that, if you're looking at an image, a 2D image versus a 3D model, there's a lot less information in the 2D image. Each dimension of space adds like a ton of extra information. So when you look at an image, you're actually looking at like a kind of a compressed, flattened version of the full thing, right? But it is possible to encode their information about the 3D surroundings, right? Like you could imagine giving each pixel like a label that says how far away it is, and encoding the information that way. And that's kind of what these holograms are essentially doing.
Yeah, I think part of the thing is that because humans, when we perceive something, ultimately our brain processes kind of like a 2D image-ish, right? Because when light comes into our eyes, we don't see the full information. We only see part of it. So it's quite easy to fool the eyes, but it's not. But to really create a real thing, that's a different story. But of course, there's another question: be like, to what extent do we mean the real thing, the 3D thing versus the 2D thing? Like, what exactly is the difference?
So Tim, you mentioned something about you don't see the full information. What does that mean?
Yeah,
where did information come from?
Yeah, like for example, in order for us to see how far away, let's say, my hand is or the car is, we don't actually look at, like, we don't actually use all the information of the light signal that comes to us, right? We use like parallax to kind of give you a sense of how far away the object is. So we're not utilizing all the information. So when the light hits the car and it's further away, there's this what we call the phase information, like the shape of the light that comes through, that encodes how far away the object was. But to humans, we don't necessarily utilize all of it, basically. So that's why it's easier to just fool the eyes versus we create the whole thing, the whole 3D thing.
Huh. So this is just as it pertains to light. It wouldn't actually mean like creating a actual object from a 2D thing.
Right. Yeah, at least that's, technologically speaking, what the hologram technology is.
Although we should mention that even in the Star Wars thing, probably they were reconstructing just the surface of Princess Leia's body, right? Not the entire interior, because that would be
right.
Any extra good.
Yeah, I would imagine it's just like maybe some glass. Like imagine we were trying to bring the Star Wars thing to life. You just maybe have like a globe or something, some kind of toy globe, and then you just shoot laser out so that when you look at it from the outside, it almost looks like Princess Leia or whatever character is doing animations and whatnot. But really, inside the globe, something else is happening. Like clearly.
So one question that comes to mind is like, whenever I look at things, I can only see the surface of it and I can't really see the inside. If I open something up, I just see more surface. So does that translate into like things we can only know about things is based on the surface? Or what do you guys think? Like, does a volume actually exist in a certain sense?
Yeah, I mean, like you can shoot like like X-rays essentially are our standard way of getting around this volume issue, right? You have light that can penetrate to different depths and reflect back, and they can give you a sense of what's inside of the material. But I mean, the kind of holograms that we'd use for communication probably wouldn't do that because it's so much extra work.
Yeah,
Oh, go ahead, Tim. Sorry.
Yeah, I think that's an excellent question, right? It's like, it might sound like a silly question, like does the volume of something actually exist? Like, it's silly, right? It's like if I have a box of cookies, yeah, I can reach into the jar of cookie and take stuff out, and eat it, whatever, right? But it actually turns out in the realms of fundamental physics, that's not so obvious actually, and I think the answer is weirder than you think. So
how weird are we talking here?
Yeah, so
Hit on me.
Yeah, I guess this is how we segue into the realms of quantum gravity, and of course, it all comes back to the idea of a black hole, basically. So and you might think, oh, who cares? We don't have black holes, but the mere fact that you can turn anything into a black hole technically makes this really interesting. Like for example, let's say I have a jar of cookies, and say, hey, I can always reach into the jar of cookies and grab a cookie out. So the inside of the jar clearly exists, right?
Mm-hmm.
But what if I'm crazy and I compress the jar of cookie like into a smaller and smaller shape? And let's say I just go to the extreme. I compress it so much that at some point it forms a black hole, right? I can no longer reach in to grab the cookie from the jar anymore, if you can call that cookie. So then you can ask the same question again. Well, does the inside of the jar exist? Because now it's inside a black hole, because you can never retrieve things from the black hole. Does it exist or not? Right? So that becomes intriguing.
So how does the holographic principle apply to black holes? Or is there such a correspondence? Or is that just a fiction?
Yeah,
well, so let's say what the holographic principle is first.
Yes. I was using it very loosely. Go ahead, Mikey. Put you on the spot. Let's do it.
Okay. Yeah, I mean, the holographic principle is kind of what Tim was alluding to. It's the idea that you don't need volume to describe volume, right? So I don't know. The way I think about it is the holographic principle is essentially like computer code, right? Like you write like a simulation software, like, I don't know, in Unity or something. And, the computer code that you write looks nothing like the actual thing that's rendered, right? The actual computer code lives in 2 dimensions. It's just text on paper, but it has all the information you need to render this 3D environment. And the holographic principle, it started out with this interesting observation that such a thing could be observed in physics, that even though our universe seems to be three-dimensional, it can be written in sort of a two-dimensional language, kind of like computer code, that looks almost nothing like the universe that we see around us, yet describes the same dynamics, makes the same predictions, and all those things. So the Hologram principle is essentially an extension of this, the hypothesis that maybe volume isn't a fundamental thing. Maybe everything is a holographic projection, in a manner that's not unlike Star Wars.
Yeah, let me just add that it to some extent it's not just a conjecture. This principle is very real in the realms of black holes, right? So imagine going back to the idea. Let's say I took my jar of cookie, I compressed it down into a black hole, and one of the most fundamental laws of nature in quantum physics is the conservation of information. Basically saying that, hey, the fact that there's cookies, doesn't leave us. You can crumble the cookie, you can compress it and whatnot. That still exists, right? And at some point you crush that jar of cookie into a black hole, you can no longer reach into the black hole. So the only thing you can observe from the black hole is the surface of the black hole, right? And in this scenario, the holographic principle is very real. Basically, it tells you that all the information about the cookie jar is encoded by the surface of a black hole. So it's very real that, you can't, to some extent, like you can argue, if you cannot go, retrieve things from the inside of the black hole, then it really is just described by the surface. So really, whatever was used to create that black hole, the information is holographically projected from the surface of the black hole.
Yeah, but black holes seem, I'm going to take devil's advocate. Black holes seem like a very special case. And I mean, I'm looking at you, like, is all the information about you on your surface? You have volume. You're not a black hole. What's going on here? Like, does it apply to outside of black holes or just only black holes?
It's almost like it's a conjecture that you can take the volume of Tim and unfold it on the 2D surface, right? And all the same things would play out. What 3D Tim is doing is what 2D Tim is doing.
Yeah, like imagine if I hoard all the matter in the universe, such that, let's say this room I'm in, if I hoard all the matter and collapse my room into the black hole, then what was originally me to an outsider must be encoded by that surface of a black hole that I formed. But of course, you can play time backward, right? You can follow all the code backward. That means even before I formed the black hole, all that information must already exist on the surface of the black hole. So it's kind of like a small leap of faith argument that says, hey, if at the end of the day, all that info is encoded by the surface of that black hole, like does the fact that it forms a black hole really matter that much? It should have been way from the get-go, way from the beginning, that the information was already there.
Yeah, it's kind of I get it. It's kind of a leap of faith argument with the black holes, but it's based on some bedrock principles, right? It's based on the idea that if you're outside the black hole, then nothing that happens inside the black hole can. What am I trying to say? I just lost my train of thought.
Well, you can't see the volume, basically. It's like the cookie jar. You cannot reach into the cookie jar.
Yeah, but it has to, doesn't it also have to do with the fact that if you're far enough away from the black hole, then nothing that happens inside the black hole can really affect your reality?
Yeah, to some extent, right? Like you really the bulk is gone, kind of. The inside doesn't exist anymore.
Yeah, for this not to be true, you would have to assume that there's some really drastic things happening in terms of like, information going into a black hole, disappearing, and suddenly becomes unretrievable to someone far away.
So, but it's okay. But let me just add that it's not just some totally theoretical thought, even though it is very theoretical. Like people have built mathematical models because the whole thing is super hard to calculate, right? You can say, oh, how do I describe dynamics of a black hole nearby? Like nobody knows. But in some toy theoretical model, like string theory and whatnot, people have cooked up thought experiments of taking some physical objects, turning it into a black hole, and describing the whole system just using the sort of like the surface of the black hole, right? So even though the physics happens in the bulk, right? There are particles in the volume that interact. The only thing you need to describe the system is just the surface, right? So this is almost like literally kind of like a hologram, basically.
I think what Sahil is saying, how do you know this isn't just a special case with string theory or is a special case with black holes?
Yeah, I mean, it's,
Yeah.
I think you could argue that, but like,
it's getting harder and harder to argue that as like by the year. I mean, lately it started out as just like kind of a curious thing. Oh, look, in string theory, this is true. Oh, look, like if you assume information preservation is true, something like this has to be true. Well, over the last few years, people have been finding more and more examples of, I think, evidence for the fact that this could be a universal behavior.
yeah, I mean, I guess you could argue maybe there's some small confirmation bias because if, you know, but I think people have tried to do different tests. They set up different scenarios where they can do calculations. So this is the way the field works. It's like, hey, let's set up a scenario where some physical objects form something like a black hole. It doesn't have to be a black hole, but then where you have a situation where there's some physics in a volume, and then you can also, it also has a surface area that bound that region. And you can try to say, you can try to do two calculations. Can I do a calculation that describes the physics of the boundary versus calculation that describes physics in the volume? And usually these are two totally different descriptions. And then you can say, hey, do they give the same answer? And in many cases, they do in some ways. And so I would say it just hasn't failed. And although maybe I'm not familiar with the literature enough, but there has been many different scenarios people set up where, yeah, they show that the surface is enough to capture everything about the bulk. It's almost like a jar of cookie. If you just look at the outside of the jar of a cookie, you can already infer what's inside, kind of.
Where did this extra dimension go? Because now we're talking from 3 to like 2 dimensions. Why is it? I don't know. What do you lose? Like, is there extra redundancy or like what's going on?
That's the thing. It's shocking that you don't lose anything, right? It's shocking that there can be exact correspondence. You would think that if you're like, you know, like in the Star Wars hologram, if you're projecting from 2 dimensions, you would think that you're missing something. Like maybe you're only getting the surface. There's no way you can get every single atom and molecule inside Princess Leia's body, right? From a projection, but it turns out that the laws of physics imply that you can. And if you can, that's a way more efficient way to store things. So why wouldn't nature take advantage of that?
Yeah, I actually did this, you know, when someone first, like, you know, if you're not too familiar with how gravity works, yeah, you it might just seem like, this just totally does not work. Like, why? How can it ever work, right? Like, you can imagine if you have a cube, right, and imagine you're stacking cubes, right? Like the number of, you're stacking Lego, right? The number of Lego pieces. Imagine you have I don't know, like a 2 by 2 by 2 cube, right? The number of Lego pieces is going to go like 2 times 2 times 2. Right, that's definitively larger than the area, which is 2 times 2, like 4 versus 8. You know, the scale is different. Right, in the beginning, you're like, oh, that totally just does not work. How can it ever work? Right, but you have to be careful. Gravity is the key here. Imagine you try to provide a counterexample. Let's say, Sahil, you try to say, Tim, you're wrong. The volume is not the same thing as the area because I can fit more and more in a volume. Let's say you try to do that. You're going to throw more and more things in a volume, more and more and more, right? At some point, you know, gravity becomes important. You put too many things in a volume, it forms a black hole. Yeah. Right. So basically, the problem with black holes is it gives you an upper bound of things you can stuff in an area. You know, that's sort of the crux. It gives you an upper bound, and that upper bound goes like the area. I mean, that just is. So like you try to stuff your volume and you end up with an area. So that's the shocking thing, right? And it tells you that, look, the limit is not how much space you have, it's how much area it's encompassing. So that's weird.
Yeah, it's funny because black holes are kind of inescapable for the reason that Tim said, but also for the reason that if you zoom time, you know, 1 trillion years into the future, everything's going to be black holes. And so then what we're saying now will approximately be true anyway.
So I guess like, I mean, so you're talking about stuffing like in the limit as you stuff things into a small space. What about like not in the limit, like you as you exist, Tim, like, because we're talking about like if I imagine squeezing you down to a small enough size where you become a black hole, then I understand it's the area. But what about you as you are right now, like in the state of matter you're in?
I think the way to think about it is that in the way Tim is right now, it's not obvious that he could be painted on a surface while retaining everything there is about Tim. But if you think about Tim becoming a black hole, it gives you a hint for how that could happen, you know?
Yeah.
Yeah,
so you can imagine there's a surface, like imagine the entire universe ultimately would collapse into one single black hole, and just imagine that surface. And that surface has many pixels, right? It's the densest pixel possible. And basically all the information that ever existed on this universe ever will eventually get funneled into those pixels on that surface, right? So, and in space and time. So what I'm doing right now, moving around, all that info will eventually funnel through, projected in space and time into those pixels. So in every real sense, that's kind of like a hologram.
So how is Tim described? Everything Tim is doing right now, everything that makes Tim Tim is being ejected out at a rapid pace. And when he dies, they'll be dispersed locally, but they'll always be painted on the boundary of the universe in the infinitely far future. And if you think of our universe as a big black hole and we're inside of it, then the circle completes.
Wait, how can you think of the universe as a black hole, or what do you mean?
Well, just say we took everything in the universe and collapsed into a black hole. Would we necessarily even be able to tell that happened? We'd be inside the black hole, right? So.
Yeah, I'm not sure. Yeah, I mean that might be where the universe is headed.
I think the surface of our universe is the surface of a black hole. So kind of hard for me to.
I mean, it doesn't necessarily have to be a black hole, right? Just the mere fact that it could form a black hole, and we don't, but we don't necessarily care. So, yeah, I think the thing is that surface is extremely dense. Like the pixel is extremely dense. It's the densest pixel, I guess the highest resolution possible, right? It's like a Planck, each pixel size is like a Planck length. It's like 10 to the negative 18, meters. It's like small beyond imagination, but that's the ultimate pixel. What do you call it? The ultimate projector, right? This is.
Yeah, is that the way to think about it? It's basically it can encode volume because it's such an efficient projector, and so efficient it actually keeps redundant copies of the volume.
What do you mean it keeps redundant copies of the volume?
Oh, we shouldn't get into that now, but I mean.
Okay.
It's a curious thing that people have noted that this projection actually also has redundant copies of the interior, not just one copy. It's not a 1-to-1 mapping, it's at least a 3-to-1 mapping.
Yeah, so this image is stranger than you think. I don't think anyone knows exactly how this projection works.
They're still working with the details for sure.
Yeah, it's very complicated, but I guess, the entire universe is just, it's a painting of the entire universe, by quantum physics.
Wow, that's very poetic.
I think what's the word? Like spiritually accurate.
Yeah. So I guess we only have a few more minutes till we gotta go, but I guess Mikey, you got my curiosity up. I guess us being inside of a black hole, how does that work? Is that too long of a discussion?
I mean, it's too speculative right now. I mean, people have noticed some eerie parallels between what the boundary of the universe, the properties of the boundary of the universe, and the properties of the boundary of a black hole. Mm-hmm. There's absolutely no kind of evidence for the fact that we actually live in like a black hole similar to the kinds we observe, but I just think it's really funny that people say the Big Bang is not accurate. We shouldn't think about it that way because it's not really an explosion, but it has a lot of properties that also kind of are similar with, like a supernova that creates a black hole. It's like an extreme density of matter. I don't know. I think there's room there for me to just fantasize, and no one can tell me I'm wrong because no one knows the answer.
Fair. So yeah, so I think on that note, we should give our concluding remarks. Tim, do you have anything you want to end with?
Yeah, I would say it seems like a strange question at first. Like, who would have ever thought, like we can think of the universe as a hologram, but sometimes I guess life is like stranger than fiction. It's almost like like sometimes these ideas are just like that. It's just strange enough, but not so crazy that like it's like maybe it does make sense, right? And we have more and more theoretical evidence of this holographic principle, and it gives you some, I think a lot of times we talk about theoretical physics and whatnot, but it gives you a lot of things to think about, how kind of philosophically, right? We live in this world. We think that the table exists, the computer exists, and of course these are very real. We do feel them. We do interact with them. But just like a hologram, right? When we interacting with it, we're actually not interacting with, let's say, like even though the world looks 3D, we're kind of not utilizing all of the 3D features, right? There's still some limit in how much stuff you can pack it in. So it's not crazy to say that maybe some of that it's kind of an illusion, right? We're not really completely living in this 3D realm, right? It's just an approximation in some ways. So I think this, it's speculative in some ways, but it's a very, very intriguing thought. And I'll be excited to see in the future, like where we go with this.
The only thing I would add to that is to say that I think all of this sounds like a little bit more natural if you assume that the universe is somehow a simulation on a quantum computer. I just wanted to just draw. And it kind of makes sense that you'd have an efficient representation that has redundant copies of the interior, sort of encoded on the exterior. I don't know much about development, like computer science, DevOps, but I assume that God is better at it than I am. It kind of seems like a cool design.
Very, very interesting. So like triple redundancy, nature has been built into it. That's what you're saying. Yeah. So on that note, I think we should end here, and I'd like to thank everybody for joining us, and we'll see you all next week.
Yeah, see you all next week.
Yeah.
Bye.
Bye.
Hey, so I had a hard
Recording
cut off.
stopped.
I got a little extension. Do you guys want to talk about next week or?